Okay, number 9, there's 4 terms. And so the hint is if there's 4 terms, you're going to use grouping. And if I group, I kind of want to group these two guys together. My 30p cubed and 5p. So if I go 30p cubed plus 5p, I know the GCF is 5p. I can divide them both by 5p. So I'm going to rewrite it as this: 5p times 6p squared plus 1. Okay, now my second group is going to be this. My second group are going to be these two guys right here. So negative 12p squared minus 2. And I can divide these both. I'm going to divide by negative 2. And it's going to be rewritten as this: negative 2 times 6p squared plus 1. And there's your GCF, 6p squared plus 1. So your answer is going to be 6p squared plus 1 times 5p minus 2. 5p minus 2. Number 11. Okay, since there's only 2 terms and I've got a cube, your hint is probably a sum of cubes or a difference of cubes. So first of all, I'm going to always hunt for a GCF. And I know that 2x cubed and 54 can be divided, both of those can be divided by 2. So move number 1 is going to be this: 2 times x cubed plus 27. Okay, now I love 27 because 27 is a cube. And move number 2 is to rewrite this 27 as a cube, and it is going to be 3 cubed. Okay, now move number 3, I need to assign my a and b. And a is just the first term without the exponent, so a is going to be x, and b is going to be the second term without an exponent, so b is going to be 3. Alright, my final answer, looks like this is only a 3-step problem, is going to be 3 times a plus b. You're going to use this formula right here: a plus b times quantity a squared minus a times b plus b squared. That's the formula for sum of cubes. So I'm going to go x plus 3 times x squared minus 3x plus 9. That is it. 13. 16 squared minus 9. This one is actually kind of a good problem. These are both perfect squares, 16 and 9. So, and this is a difference of perfect squares. This is kind of like a conjugate. You're going to go 4x minus 3 times 4x plus 3. So here's the conjugate. Here's what I'm talking about. 4x minus 3 and 4x plus 3. If you ever multiply something by its conjugate, what happens is these middle terms are going to cancel out. 4x times 4x is 16x squared. 4x times 3 is 12x. A negative 3 times 4x is negative 12x. And your last times last is a negative 9. So these middle terms are what's going to cancel. 16x squared minus 9. That's what we started with. So with your work with conjugates, you just recognize this as 4x minus 3 times 4x plus 3, and you're done. That's your answer right there. 15. Alright, radicals. Simplifying radicals. Square root of 6 is simplified as far as it can go. So is 3, but 24 is not. See if you can rewrite the square root of 24 as the product of two numbers, one of them being a perfect square. And you are going to know that square root of 24 can be divided by 4. So I'm going to rewrite that as square root of 4 times square root of 6. I do that because of this right here. Square root of 4 is going to simplify. That's a whole number. Square root of 4 is 2. So you have 2 times 2, which is just 4. So 4 times the square root of 6 replaces 2 times the square root of 24. Alright, now your like terms, this is an addition problem. You can only add like terms, which is this first and this last term. 4 square roots of 6 subtract 3 square roots of 6 is going to leave you with just 1 square root of 6 plus 2 square roots of 3. That is your final answer. You cannot combine square roots of 6 and square roots of 3, so you're done. And you can leave out the 1. You don't need to write the 1. 17. This is a multiplication problem. And you're going to have to do the distributive property. You're going to have to times this to this. And in front of this is an invisible 1. So when you're multiplying, you multiply your coefficients. 1 times a negative 5, that's a negative 5. And you multiply what's underneath your radicals. So your radicands. 3a times 6a is 18a squared. And then let's go this way. Let's do plus square root of 30a squared. Alright, now let's see if we can clean it up. 18, can you rewrite 18 as the product of two numbers? 18 can be divided by 9 and 2. So I'm going to go negative 5 times the square root of 9 times the square root of 2, and you still have this, times square root of my letters, a squared. And if you rewrite it like that, square root of 9 is going to clean up. Square root of 9 is a 3. So you really have a negative 5 times a 3, and that's a negative 15. And this guy right here is going to clean up. The square root of a squared is just a, so that comes out. So the only thing left under the radical is just a 2. Alright, so negative 5 times the square root of 18a squared cleans up to this. Negative 15a times the square root of 2. Now your next one, let's see if it can clean up. 30. Can you divide 30 by 25, 16, 9, or 4? No, you can't. So the 30 stays put, but the a squared, square root of a squared is just a. So on the outside, we're going to have an a, and underneath you're going to have 30. And that is your answer. 19. Okay, let's skip it. This ends up being a little more complicated than I wanted, and it's not going to be on the final, so don't worry about 19. 21. Here we go, radicals, simplifying radicals. Now in the denominator you have a radical, square root of 2, and you cannot have a radical in the denominator, so you're going to have to multiply the whole thing by 1. But you're going to have to get creative, and you're going to multiply it by square root of 2 divided by square root of 2, which is 1. Because you can times anything by 1 and it doesn't change it. So you do that because of this right here. Square root of 2 times square root of 2 is the square root of 4. And square root of 4 is whole number, 2. So on the bottom you really have this. You really have 3 times 2. Or you just have 6. Okay, on the top you have 5 times the square root of 2, which is just 5 times the square root of 2. And you are done. That's your answer. 23 gets a little more complex. 4 divided by 2 times square root of 2 plus square root of 3. And the trick to getting rid of this is the word conjugate. You are going to have to multiply this by the conjugate of 2 times square root of 2 plus square root of 3. So you're going to do the difference of squares. So if you're 2 times square root of 2 plus square root of 3, the conjugate of that is going to be 2 times square root of 2 minus the square root of 3. And since you're multiplying the bottom, you're going to have to also multiply the top by the same thing. Okay, this one's going to get fun. So here we go. Let's multiply the bottom. 2 times square root of 2 times 2 times square root of 2 is going to be, 2 times 2 is 4. And square root of 2 times square root of 2 is the square root of 4, or 2. So you're going to have 4 times 2. So you're going to have 8. Now, if I multiply 2 square roots of 2 times the negative square root of 3 is going to be this. It's going to be negative 2 times the square root of 6. Alright, now let's multiply my square root of 3 to the first term, and that's just going to be plus 2 square roots of 6 If I multiply my square root of 3 to the negative square root of 3, it's going to be a negative square root of 9. And the square root of 9 is just a whole number, 3. And here's what's sweet about a conjugate. These middle terms will always cancel. Negative 2 square roots of 6 plus 2 square roots of 6 is 0. So you just have this. You have 8 minus 3, which is a whole number, 5. So you cleverly changed this irrational expression into just a simple whole number, 5. Okay, now the top. You need to distribute the 4 and multiply it to both of these guys. 4 times 2 times the square root of 2 is going to be 8 times the square root of 2. And 4 times the minus square root of 3 is going to be minus 4 square roots of 3. You're done. That is your answer. 25. Okay, now you have an equation. You got an equal sign, so they want to know what is the value of x. Okay, so let's get this radical all by itself. So underneath the radical, you have a negative 7 and negative 11x. Move number 1. Let's undo this minus 6. So it's plus 6 plus 6. So you're going to have square root of a negative 7 minus 11x equals 9. Move number 2. Let's get rid of this radical. So the opposite of square rooting something is squaring something. So if you square both sides, a square root and a square cancel. So it's going to give you a negative 7 minus 11x out in the open. And on the right, you're going to have 9 squared is 81. Okay, now let's just solve for x. So let's undo the minus 7. Let's add 7, add 7. So we're going to have a negative 11x equals 88. Divide by negative 11, divide by negative 11, and you should have x equals negative 8. Okay, now you got to plug it back in and verify that it does give you a true statement, because if it gives you a false statement, then your answer is going to be no solution, no real solution. So the only way to tell is to plug it back in, and a lot of times you can do this with mental math. So a negative 11 times x, a negative 11 times a negative 8 is a positive 88. So you're going to have square root of a minus 7 plus 88. What's 88 minus 7? That's the square root of 81. The square root of 81 is 9. And 9 minus 6 really does equal 3. So it checks out. That is your answer. X equals negative 8. 27. Change this to exponential form. Alright. So this is the exact same thing as 4 times 2n in parentheses to the 5th power. That might make it a little bit easier. So if you're going to write it as an exponent, your base is going to be 2n, but it has to be in parentheses or else it's wrong. And the question is, where does the 4 go, where does the 5 go? 5 is your numerator, 4 is your denominator. But I'll bet you that's not the most correct answer. Because I'm wondering right here, if you look at this and you notice that your exponent is larger than your index, so how many 4s are there in 5? Or if you divide 5 by 4, you're going to get one whole number and then a remainder. So you could go right here, you could change this. If you change this into this right here, so how many 4s are there in 5? There's 1. So I know one of these two ends makes it out. And then what's the remainder? How many's left over? There's just 1. So underneath there is 2n. So now if we go this route, you're going to have 2n times, how do you change this guy right here to an exponent? Well, this index is 2, and this is all raised to the 1 power, so it's going to be 2n to the 1/2. So here's your answer compared to this answer, and they're both the same thing, but if you have to choose one over the other, this guy right here is probably the most correct. But if you get this for the final, this guy right here, I'll give you full credit. Okay, number 29. Change this to a radical form. And here we go. Problem is you got a negative exponent. N to the negative 5 halves. So let's fix that real quick. Let's go 1 over n to the 5 halves. Okay, move number 1. Now move number 2. Maybe we could do this real quick. We could change it to a radical right here. So n to the 5 halves is really going to be radical n, and my exponents can be 5, and my index is 2. So there we go. But now we got to do a couple more steps. First of all, let's simplify this. My exponent 5 is greater than my index, so I know some of these n's are going to come out. How many n's make it out? How many 2's are there in 5? There are 2. So n squared makes it out, and 2 times 2 is 4. 5 minus 4 is 1, so one of these guys is left over. Okay, that looks pretty good. Except for in the denominator you've got a square root, and you've got a radical, and you can't have a radical in the denominator, so it's easy fix. Times it by 1, times it by a clever one, times the top by square root of n, and times the bottom by square root of n. Now your denominator, square root of n times square root of n is square root of n squared, and square root of n squared is just n. So you're going to have this n squared times n, and that's going to total on the bottom n cubed. Okay, on top you're going to have 1 times square root of n, which is just square root of n. That is your answer.